equations that you've dealt with so far, we've never called them this because they're the only ones you've ever dealt with, so you didn't have to compare and contrast, but they are called rectangular. If you didn't know that, that is what we call those. They are rectangular, all the equations you've dealt with up until this point. So they are either y in terms of x or x in terms of y. I didn't mean to make in terms all scrunched together like that. That should be two different words, but I'm writing with pen, so I can't erase it, and I shouldn't be doing that. But I just prefer writing with pen. So you either have y in terms of x, which means you have y equals, and then some statement with x's in it. So like y equals x squared plus 2, or y equals 4 square root of x minus 9, or y equals sine of x, okay? Or x in terms of y. So you would have x equals, 4y plus 7. Do you guys hear what I'm saying here? Equations, okay? They're rectangular. What we're going to move into are parametric equations, which means you have both x and y in terms, I wish that was just one word, of a parameter, which is usually t. Sometimes it's something else, but usually it's t. You've actually done this before. Do you remember related rates when you had everything in terms of time and you had dv dt and dA dt, dx dt, dy dt? It's that, okay? So you've technically already sort of done this, right? To eliminate the parameter, you're going to solve for t in one equation and substitute into the other equation. Basically, it's just a lot of algebra. So if your algebra skills are good, then you'll be just fine. We're not going to do any calculus with parametric equations today. Today is about understanding what a parametric equation is and how it works. I'm not going to ask you to do derivatives and integrals with these until you understand what they are. Does that make sense? Also, and we talked about this before, do you remember how I said we're going to fly through all the A-B stuff because you did it last year? Okay, and then I said once we get to the B-C stuff, we're going to pump the brakes because you're seeing it for the first time. Welcome to that day. Okay, so you're going to feel things slow down a whole lot because you haven't seen this before. So we're not even going to do really any calculus today. Today is just about you understanding what a parametric equation is and how to graph it before we then go and do, velocity and acceleration and all the other fun stuff with it, right? So first thing we're going to do for this is we're going to make our table. You're going to have t, you're going to have x, and you're going to have y. Now, sometimes they give you t values that you should stay between, and sometimes it's just, whatever. Usually you have an interval, though. This one is from -2 to 3. So I'm going to go ahead and make my list of numbers from -2 to 3. And you can do this however you want, but I like to do the whole x column and then the whole y column, so I don't have to keep switching in my mind between which equation I'm using. Do you see how you have x equals and then a statement with t in it, and then y equals and a statement with t in it? Okay, so you're going to have motion in the x direction, which is left to right, and then you're going to have motion in the y direction, which is up and down. But we're dealing with them both separately, right? So let's plug all of these numbers into our x equation. This is just arithmetic, all right? If you plug in -2, what are you going to get? -4, so good. 0. If you plug in -1, -3. If you plug in 0, -4. 1 is going to give you -3. 2 is going to give you 0. I hope you see the symmetry there. And then 3 is going to give you 5. Cool. Now we're going to do the exact same thing with our y equation. So we're going to plug all these values in for our parameter t and get all of our y values. So we're doing the motion of the y coordinate. So if you plug in -2, you're going to get -1. This would be -0.5, 0, +0.5, 1, and 3/2, which would be 1.5. When you graph this, you don't graph the parameter t. All right. So if you want to even just cover that up, I don't recommend scribbling it out because we do still kind of want those numbers. It's not like they're gone to us, but they're not going to be on your graph. This is your x-axis and this is your y-axis. You don't have a t-axis. All right. That's just your parameter. So let's all go ahead and take a minute and just plot those points. So we're going to have 0, -1. -3, -0.5, -4, 0, -3, +0.5, 0, 1, and then 5, oops, 3/2, be right there. Now, when you graph these, and we're going to stay between those points because those are the only t values that we had. If you read the directions there, it says show the orientation. That's the direction in which your particle is moving. It's particle motion. It's the direction in which your particle is moving. So our t values go from -2 to 3. So we're going to start here. This is the point that we got from -2. And it's going to go this way as we connect them. So the orientation or the order in which you go through the points is important. And here's how we indicate the orientation. You're going to put these little arrows to show which way it's going. So you can see exactly where the particle starts and then where it ends up. Cool, right? Or any thoughts or comments? Or so it does stop because we were told this is our interval for t. Technically, like mathematically, it could keep going, but we were just given this as an interval, so we are going to make it stop, right? Now, the other thing we want to do is eliminate the parameter. Would it be easier, do you want to choose the, we're all lazy, right? You want to choose the easier version. Would it be easier to get t isolated in this one, or would it be easier to get t isolated in your y equation? Good, definitely y. If you get t by itself, that's going to give you what? 2y, and you're going to take that and substitute it in for t in the other equation. So it's just a whole big lot of algebra. So we're going to get x equals 2y squared minus 4. Now, it's the 2 and the y getting squared. So you have to square both of those, and that would give you x equals 4y squared minus 4. And that is your answer with the parameter eliminated. Do you see how there's not a t anymore? Is this x in terms of y or y in terms of x? X in terms of y. Good job. Okay. And it's not a function. Do you see how it fails the vertical line test? It doesn't matter, though. It's just, your particle started here, it went this way, and it came over here. Cool, let's try it again. That was fun, right? You're going to make your table. Oops, I always forget to put t. T, x, and y. Now, we want bigger than -1. Can I plug in -1, though? No, why not? There's not an equal to, all right? Also, if you try to plug in -1, what's going to happen? You get a 0 denominator. Yes, well, sort of. It should feel like a limit. Does that feel like a limit? Because we're going to do some limits in just a minute. So I can't plug in -1, but what's a number bigger than -1? We want to keep on to. So we're going to do 0, 1, 2. Now that goes on forever and ever. So we'll just kind of see what we get. Right? So if we plug in 0 for our time in our x equation, what are we going to get? 1. And actually, you know what? I am going to have to pull out my whiteout. Why would 1 be a bad number to plug in here? Yeah, you get square root of 2, which I don't want to deal with. So I am so sorry. We'll try something. It's about 1.4. I only know that because I live in this room and do math problems, but I don't expect anyone to know that. Plus, I don't want to graph that, all right? Let's try and come up with a good t number that I could plug in so I get something I could square root. 3 is good. 8 would be good. Let's not go any further than that, though, or I think we're going to be off the grid. All right, so let's see. If we plug in 3, 3 plus 1 is 4. I can square root that. Square root of 4, 2, and so we get 1/2. Cool, or 0.5, whatever's your preference. All right, if you plug in 8, 8 plus 1 is 9. You can square root 9. That is a third, or what's 3? So 1/3, 1/3. Sorry, my brain did it faster than my hand. So now we're going to plug in all of those t values to our y equation. If you plug in 0, you're going to get 0 over 1, which is just 0. If you plug in 3, you're going to get 3 over 4. Good job. We are good at fractions. And if you plug in 8, you're going to get 8 over 9. Now, before I go to do that, I want to do my limit. We're going to do limit as time goes to -1 from the left or from the right. Let's see, if you have -1 and all the numbers bigger than it, you have to go from the right, okay? And we're going to do that for both of these equations. So this is a review of Unit 1 here. So this is good. We'll review some limits. We haven't touched limits in a while, so this will be a good review. The first thing you want to try and do is plug in the number you're approaching. So if you try and plug in -1 here, you're going to get 1/0, which does mean asymptote. We want to test a number to the right of -1. So what's a number that's to the right? I think of a number line. To the right of -1. 0 would be good, or 1, okay? I would just go 0. So if you plug in 0 here, 0 plus 1 is 1, which is positive. And in the numerator, 1 is also positive. So a positive and a positive, positive infinity. So for this one, if we plug in -1, we're going to get -1/0. So again, it's an asymptote. Except this time, if you test a number to the right of -1, we already did that, so I'm not going to do it again. That comes out positive, but your numerator is negative. So a negative over a positive gives you negative infinity. Now, if they both came out negative, then what would happen? It would be positive infinity. Two negatives are going to cancel out. All right, let's try and graph this. We're going to have to do some more limits just as a heads up, but you'll see once we graph it. You're not going to graph the t parameter, so you're just going to take these points and plot them. So 1, 0, 1/2, 3/4. I scaled it for you on purpose, so it's all kind of set up for you. All right, yeah, well, I guess it's not by thirds, though. 1/3 would be in between 1/4 and 1/2, and then 8/9 is really, really close to 1, so it's going to be kind of like that. Our x dimension was going to positive infinity. That's this away. All right. Our y dimension was going to negative infinity, which is this away. So it's going to be like off down here somewhere. So like going like that. Forever and ever and ever and ever and ever and ever. Don't put an arrow on it, though, because we have to show the orientation. We're just going to understand that this keeps on going. Now, I need to know where this side is headed. We did our limits to -1, but this says time is bigger than -1. So t goes on forever. So we're going to do our limits as t goes to infinity for both of these. And so we're going to review limits to infinity as well, which is also just good practice. Also, we're reviewing how to write limits, your limit notation. That's good, because it has been a while. I view infinity like who's in charge here. When you go out to positive or negative infinity, it's, which is the most controlling or powerful part of the equation. So if you think about plugging in like a really extra huge number here, you end up with 1 over like a gazillion, like the biggest number you can possibly think. Even if you square root a billion, it's still super large. So if you end up with 1 over a million bazillion, that is essentially 0 is where that goes to, okay? This one's a little bit different. You have t here and you have t here. They are both to the first. When it's a tie like that, what do you use as your tiebreaker? Those are called what? Coefficients. There we go. Which also both happen to be 1, and 1 over 1 is 1. So as time goes on, your x dimension goes to 0 and your y dimension goes to 1. So it's going to go to 0, 1, but will it ever actually reach there? No. So we're going to put an open circle. It's going to head there, but like never actually get there. And so the orientation of your graph is like this. going to get closer and closer and closer and closer, but never arrive at its destination, which sounds kind of sad. Now, if we want to eliminate the parameter, which one of these, x or y, would be easier, pick the easy one, easier to get t by itself? It's actually x. Why is x easier? Because look at it. There's only one t. Do you see how for y that would be really hard because you have two of them? Okay, so we're going to look at this one. What would you start doing? Algebra. What would you try and do first? You would move, so that you don't have a fraction, you're going to move all of this to the other side. So it's going to give you x times square root of all of that equals 1. The first thing you want to do is get rid of that denominator. All right, then what? Divide by x. Now we're going to be able to square. All right. What is 1 squared? 1. And x squared is x squared. And then what's your last step there? Yeah, subtract. This is a lot of good practice with algebra and fractions and limits. A lot of good stuff here. So we're going to take in the other equation. So it's going to go in for both of those t values. So it'll look like this, and it's going to look like a mess, but that's okay. It'll be 1 over x squared minus 1, fraction bar, and then 1 over x squared minus 1 plus 1. So actually what's going to happen to those? Yeah, they cancel. But I'm done playing with that. Do you see how there's no t in this anymore? There's x's and there's y's, but there's no t. We eliminated the parameter. So I'm happy with that. I think that's enough algebra for that question. It's a very rich question, though. We did a lot of stuff in there. We reviewed a lot of calculus and algebra, so I like that question. I like the next one, too. If you go ahead and flip over, what's the next one got in it? Oh, we're going to do some unit circle. Do you want to go ahead and draw a unit circle off to the side here? We're going to need it. Now, your parameter isn't t in this case. What's the parameter? Theta, which is okay. This is actually a preview of polar equations, which is going to be our next unit. I love to do that, preview something, and then when we get there, like, hey, we kind of already did this. Now, our theta is going to go from 0 to 2 pi. Make a suggestion. When you write 0 for the unit circle, call it 0 pi. It's like no pi. And then what would we want to make the next one? Yeah, pi over 2, pi, 3 pi over 2, 2 pi. And I would do the whole x column at once and then the whole y column. All right, here we go. You're going to have to watch me point to it because I don't have a better explanation than, hey, look, here's 0 pi. That's the coordinate point 1, 0. All right. Cosine is what part of the point? Good. So that's 1, but you have to multiply it by 3. So 3. Pi over 2 is up at the top. That's the coordinate 0, 1. Cosine is the 0. 0 times 3 is 0. And then some of you are going to pick up on the pattern real quick, but I'm going to walk us all the way through it. All right, at pi, that's the coordinate point -1, 0. The x coordinate is -1, but you have to times that by 3. So -3. What's the next one? 0. And then 2 pi is in the exact same place as 0 pi. That's called coterminal. Did you learn that word in pre-calculus? Or you guys call it math analysis. Coterminal means that they land in the same spot. It's a circle, so you can keep going around and around and around. Right? Now let's do y. Exact same thing, but sine is what part of the point? It's the y coordinate. So for the first one, 0 times 4 is 0. At pi over 2, it would be 1 times 4 is 4. And then 0. and then -4, and then back where you started. When you graph it, you will not graph the parameter. This is an x-axis and a y-axis, so the parameter doesn't get graphed, all right? So let's go ahead and plot those. We're going to have 3, 0, 0, 4, -3, 0, 0, -4, and then back where you started. I know, isn't that kind of cool? It kind of looks like a circle, but is it like a perfect circle? It's an oval, or we call it an ellipse. That's the official mathematical term, because it's not a radius of 3 or 4 in each direction. One side is 3, one side is 4. So it's an ellipse. But you have to put the orientation. Are we going clockwise or counterclockwise? Yeah, counterclockwise. It's going to go this way. Round and around and around. When you go to eliminate the parameter, which just means get rid of the theta, which one is easier to solve for? Does it really matter? No. Okay. Do you want to do x or y? We'll do whatever one. X. Okay. First thing you would do is divide over the 3. And then you need to undo a cosine. How would you cancel out or undo cosine? It's inverse cosine. There's 2 ways you can write it. I prefer arc cosine because I feel like that looks a little neater. What's the other way you can write it, though? Instead of arc, it's with the little -1. So if you like that better, you can do. No one is right and no one is wrong. I have, like, at these higher level math classes, I have people that get very opinionated about certain things. There's not a right or wrong way. I like arc. I just feel like it looks a little bit nicer. The -1 sometimes confuses people, but if you like the other way, that's totally fine too, right? And then you're going to take that and plug it in for theta in the other equation. So it'll be y equals 4 sine of arc cosine or inverse cosine of theta. Did you say ew? I kind of don't disagree. That does look sort of awful. Oh, did I put, oh, sorry. That's really wrong. And I'm actually kind of mad at myself that I did that. So it's wrong because I forgot the over 3. But what else is awful about that? Right. The point was to get rid of theta. Oh my gosh. Blasphemy and sacrilege. I can't believe I just did that. Jeez. Vote me off the island. All right. X over 3. There we go. The point was to get rid of theta, and I drew a theta. Oh, well, it happens. All right. We're going to write parametric equations to represent these. That means that you should have an x equals and a y equals. And I usually just start with that and like set it up blank. I made the first one about as easy as I could make it just for you to get the hang of it, because x literally equals t. Do you see that right there? So like that's the answer for x. For y, anyone want to give it a shot? Here's your equation. It'll be 1 minus t squared. X equals t, so that's it. I like to throw one like that on there sometimes too, because people will second guess themselves about that. They'll go, that's it? Like, yeah, sometimes that's it. Now this one, made this one a little tougher. What does dy dx mean? It's a derivative. It's y prime. So t equals the derivative of this. So derivative of 1 is nothing. It'll be -2x. So we want an equation for x and we want an equation for y. You said it right the first time. T over -2. If I could, can I write it as -1/2 t? Is that okay with everybody? I feel like that goes better. You're just going to divide over this -2. I prefer writing it that way. If you want to write t over -2, are you wrong? No, it's a personal preference thing. I just like having a coefficient. And then how would you get y? Well, you would take that and plug it in. So it's going to be 1 minus -1/2 t squared. For the sake of being thorough, let's figure out what that would be, because there's a squared and there's a negative and there's a fraction, and I just want to make sure we're all good. It's going to be 1 minus. Now, when you square something negative, it turns positive, but we still have subtraction there. Okay, so it's still going to be 1 minus something. 1 squared is 1, 2 squared is 4, and t squared is just t squared.